Hey guys, so today we're going to convert polar and rectangular equations. So just starting off, remember these are the equations you'll need to convert. Same deal from the coordinates. So I'm given a rectangular equation. I know it's rectangular because it's given in terms of x and y. I want to convert it to a polar equation. So that means I'm going to start off by changing x to r cosine theta. And I'm going to bring down the square, and it says plus y squared. So I'm going to change the y to r sine theta, and also bring down the square equals 16. Now kind of using algebra as the baseline again, 5x squared. If I were to square 5x, I would get 25x squared, meaning I square the 5 and the x. So same deal here. I'm going to square the r and cosine. And in the next term, also square r and sine. And if I look between the two terms are separated by plus and minus signs, I have a GCF of r squared. So if I factor r squared out of each term, I'll be left with cosine squared for the first term, and I will be left with sine squared for the second term, equals 16. Now remember that cosine squared plus sine squared comes from the Pythagorean identities. So the Pythagorean identity states that cosine squared, plus sine squared equals 1. So that means I can change this to just 1. Bring everything else down. It's being multiplied to r squared. It equals to 16. R squared times 1 is just r squared. So r squared equals 16. And if I square root both sides to get rid of the square, I'll get r equals 4. Okay, moving on from here. By the way, you'll know that you're done because any values of x and y will be gone. It'll be a polar equation if all variables are in terms of r or theta. And you'll know you'll fully converted it to rectangular if everything is just in terms of x and y. You may have to simplify the expression, but other than that, that's pretty much how you'll know that you fully converted it. Okay, so moving on to another one. Let's say I give you x squared plus y squared minus 3y equals 0. Now this is in rectangular form because everything is in terms of x and y. So I'm going to do what I did before. I'm going to change x to r cosine theta. It's squared again, so I'm going to bring down the squared, plus, instead of y, it'll say r times sine of theta. Again, it's squared, minus 3 times y would be replaced with r sine theta equals 0. So this is now a polar equation. I just have to simplify it. So I'm going to square the r and cosine as I did in the previous problem, and square the r and the sine, and minus 3r sine theta. Okay, so I have the same deal I had before going on here. I have a GCF of r squared. Bring down the r squared and factor it out of each term, which leaves me with cosine squared plus sine squared. Bring down the rest. Minus 3r sine theta equals 0. Sorry, I keep meaning to change the color, but it's not happening. And what we have here is, once again, the same Pythagorean identity. So we know that this value is 1. Everything else comes right down. So I'm going to bring down the r squared. I'm going to bring down minus 3r sine of theta equals 0. So this gives me r squared minus 3r sine theta equals 0. And I do have a GCF again. Between these two terms, the GCF would be r. They do have r in common, so I'm going to factor that out. And if I factor r out of r squared, I'm left with r. If I factor r out of minus 3r sine theta, I would be left with minus 3 sine theta equals 0. And as you already know, it's factored, the other side is 0, so I can use what's called zero product property, meaning set each factor equal to 0. So I could set r equals to 0, and I could set, I'm out of room, so I'm going to put that here, r minus 3 sine theta equals 0. Usually polar equations, you'll see it as r equals, so I'm going to add this 3 sine theta to both sides, and I will get the other equation, which is r equals 3 times sine of theta. All right, guys, I hope this helps.